A pleasant evening to each and everyone. My name is Cbmec, and in this video, we will be discussing about the Toshiba. Toshiba, producer of the first notebook computer. Tokyo Shibaura Denki or Tokyo Shibaura Electric Corporation was formed in 1939 by a merge of two highly innovative Japanese companies, Shibaura Senkaku Denki or Shibaura Engineering Works, which manufactured transformers, electrical motors, hydroelectric generators, X-ray tubes, and Tokyo Electric Company, which produced light bulbs, radio receiver, cathode rays tube. The company was soon after known as Toshiba, which became its official name in 1978. Toshiba became the first company in Japan to make fluorescent lamps in 1940, radar in 1942, broadcasting equipment in 1952, digital computers in 1954. Toshiba also became the first in the world to produce powerful 1 megabyte RAM and first laptop computers, the first laptop computer, the T3100 both in 1985. Toshiba built its strength in notebook PC market by beating its competitors to the market with aggressively priced technologically innovative products. Competition in the notebook PC market is fierce, and Toshiba can retain its position as a market leader only by relentlessly improving its manufacturing process and lowering its costs. Dell Computer, a formidable competitor, and seeks to minimize its cost by assembling to order and selling directly to customers. Toshiba has significant advantage over Dell that stem largely from huge investment in technologies such as thin film transistors or TFT, color display, hard disk drive, lithium-ion batteries, and DVD drives. In addition, by forming partnerships and joint venture with other giant industries, Toshiba can share the risk of developing expensive new technologies. That's all. Thank you.
Good day. In this section of our report, I am going to talk about how production processes are organized. The way production processes are organized plays a crucial role in operational efficiency. The selection of these processes, also known as process selection, depends on factors like product type, product volume, and required customization. The goal is to align production methods with business needs for cost, efficiency, quality, and speed. Let's talk about process selection. So, what is process selection? Process selection refers to the strategic decision of choosing the most suitable production process for a product or service. This depends on the product's complexity and volume. For instance, a low volume, highly customized product might require a project layout, while a high volume standardized products would benefit from an assembly line. Selecting the wrong process could lead to inefficiency, increased cost, and poor quality, while selecting the correct process could lead to more efficiency, less cost, and higher quality control. Next, I'm going to talk about types of production process. The first of this is project layout. Project layout. This layout suits large one-off projects where the product remains stationary and workers, tools, and equipment move to it. It's common in industries like construction and aerospace. Next is work centers. Work centers, also known as job shops, group similar equipment or tasks together. Products move between stations based on their specific needs. This layout is best for low-volume customized production. Next is manufacturing cell. Manufacturing cells are organized for the production of items with similar requirements. The cells allow for moderate customization while maintaining efficiency for small to medium volume production. Next is assembly line. Assembly lines are used for high volume standardized products. The product moves along a series of stations, each performing a specific task, making it ideal for repetitive tasks such as in automobile manufacturing. Last of this is continuous process. This layout is similar to an assembly line but operates without stops, making it suitable for production of standardized high-volume commodities like chemicals. It is highly automated and efficient for uninterrupted production. Here, I'm going to talk about the product process matrix. The product process matrix illustrates the relationship between production process and product characteristics, focusing on the product volume and standardization. The product process matrix is a strategic framework that helps organizations align their production process with product characteristics, specifically focusing on product volume and standardization. It illustrates how different production processes fit different types of products based on these two dimensions. Here we have the chart or the product process matrix. As you can see from its vertical axis, the product standardization, it ranges from low customized unique products or one-of-a-kind products at the top to high standardized mass-produced items at the bottom of its vertical axis. And for its horizontal axis, it represents the product volume. It ranges from low, small quantities or project-based production to on the left to high larger scale production on the right. So you can see I'm going to discuss the layout. On the upper left part is for low volume highly customized products. This example is construction. The construction could benefit from it. Work center, also upper left for low volume but more standardized products. Examples are machine shops. Next is manufacturing cell. It is found in the middle of the matrix. Suitable for moderate volume and standardization. Example of this is electronics assembly. And assembly line can be found on the lower right for high volume and high standardization production. Example of this is automobile manufacturing. And next is continuous process. Can be found at lower right corner for non-stop production of standardized commodities. Example of this is oil refining. So, in short, as product volume and standardization increase, business should transition to more structured and automated processes. This matrix helps organizations align their production strategies with market demands, optimizing efficiency and effectiveness. In conclusion, process selection, and organization of production layouts are key to operational success. By understanding product process matrix and choosing the right process, whether it's a project layout for one-off items or continuous process for mass production, companies can optimize efficiency and meet market demands effectively with the help of these.
Good day, everyone. My name is Hazel Pisalara, and today we will be tackling about break-even analysis. Break-even analysis determines the number of units or amount of revenue that's needed to cover your business total cost. The break-even point, you aren't losing or making any money, but all the costs associated with your business will have been covered. I'll give you an example of a break-even analysis. Eto, merong isang bakery na bumalak na bumili ng bagong oven. Tapos, ang cost ng oven is 50,000. Nag-estimate yung bakery na kaya nito makaproduce ng additional 100 na tinapay araw-araw gamit ang bagong oven. And ang presyo ng isang tinapay is 3 pesos. Ang cost naman niya is 1.50. Kasama na yung ingredients and yung labor. Approximately, ang kailangan na mabenta nila is 3,334 na tinapay. Kung mas mataas pa ang 334,000 na tinapay, magkakaroon ito ng profit. Pero kapag mas mababa pa yung 3,334 is magkakaroon na ito ng loss. I'll give you the formula for break-even point. The break-even formula is fixed cost divided by variable cost minus the selling price. For example, you have a fixed cost that is maybe 1 million pesos. And your variable cost is 600 pesos. Your selling price is 400 pesos. Your selling price, your variable and selling price, you will minus the two of those. And my calculation is 400 minus 600, 200. The fixed cost remains constant, which is 1 million then. 1 million divided by 200. And your total unit is 5,000. That's the formula.
Good day, everyone. My name is Fatima Faiza David, and I will discuss how to design a production system. Designing a production system focuses on different layout types and their application in manufacturing. We have the project layout, work centers, manufacturing cells, assembly lines, and continuous process layouts. We will start by introducing the concept of project layout. This is where materials and equipment are arranged around a central point, emphasizing the order of use and minimizing the movement difficulty. An example of this is building custom yachts, where heavy engine parts are placed close to the hull for easy access, while less frequently used parts are located further away. Second is the work centers. These are the departments focused on a specific type of operation. The example given is a work center for drilling holes, showcasing the specialization of these units. Next are the concept of manufacturing cells. These are designed to group machines that work on similar products with similar shapes and processing requirements. This highlights the use of computer-aided design and assembly work in developing the cells. Lastly, assembly lines and continuous process layouts, which are designed for building products by moving them through a series of stations in a progressive manner. This process involves linking stations with material handling devices and managing the pace of the process. It emphasizes the use of continuous flow processes where the product moves continuously as opposed to assembly line where product stops at each station.
Assembly line design. An assembly line is a production method where a product goes to different workstations to be fully assembled. Each of these workstations plays a different role that contributes to the overall completion of the product. Assembly line balancing. It is the process of evenly distributing tasks across each station to ensure efficiency and reduce the time required to produce the product. Precedence relationship. It is a challenge in assembly line balancing, referring to the order in which tasks in production should be completed and what follows each task. The most common example of an assembly line is a moving conveyor. The conveyor's movement shows the product's movement from one station to another in a uniform time interval called workstation cycle time. Workstation cycle time is a time needed to complete the operation at one station. Remember that the total work to be performed at a workstation is equal to the sum of the tasks assigned to that workstation.
Hi, I am Rikajin Arpolidario and I will discuss to you the three formulas presented in assembly line balancing. We have the first formula, which is the workstation cycle time. We will determine here how much time will it take for one task to be produced or for one good to be produced. We have the formula of C is equals to production time per day all over required output per day in units. Then next, we have the formula of minimum number of workstation. We will determine how many workstation will we have in order to produce these goods. The formula will be N is equals to sum of task time all over workstation cycle time. For the last formula, we have the efficiency. E is equals to sum of all task time all over minimum number of workstation multiplied to workstation cycle time.
We had an example here in assembly line balancing. We have the Model J wagon is to be assembled on a conveyor belt. 500 wagons are required per day. Production time per day is 420 minutes. And the assembly steps and times for the wagon are given in Exhibit 4.4. So what we're going to find out here is to find the balance and minimize the number of workstations subject to cycle time and precedence constraints. So in order for us to solve that problem, we are going to follow the six steps of the assembly line balance. Step 1 is we will going to analyze the problem and make it in a table for it to be easier
next one, we will going to do the precedence graph for us to know what precede the next task. For the second step, we have the workstation cycle time. We're going to determine how much time will it take for one wagon to be made or to be produced. We have the formula of C is equals to production time per day all over output per day. It is stated in the question or in the problem that the production time per day is 420 minutes, and since the problem is in seconds, we will going to convert it into seconds. So how many seconds are there in 420 minutes? We will going to multiply it into 60 seconds because there are 60 seconds in 1 minute. Then the results will be 25,200. Then it is also stated in the problem or in the situation that the output per day should be 500 wagons. So you should copy the 500, then divide the 25,200 all over 500. Then the answer will be 50.4. So for the third step, we will going to determine what is the minimum number of workstation. We're going to have the equation of N is equals to T all over C. T means the sum of all task time. Since how to determine the sum of all task time, we are going to add all the task time. It is stated in here, task time in seconds. So we're going to add all of this in order to get the 195. So our sum of all task time will be 195. So the letter C is the workstation cycle time. We're going to copy the answer or what we solved earlier into the denominator. So we're going to divide it, and the answer will be 3.87. Or because there is no half workstation, we will going to round it up always. Even if the next number is lower than 8 or lower than 5, we're going to round it up. Lastly, we have the efficiency calculation. We have the efficiency is equals to T, or the sum of all task time, all over NA, or the minimum number of workstation required, multiplied to workstation cycle time, or C. We determined earlier that 195 is the sum of all task time because we add all the task time in seconds of all the tasks. Then 5 is our workstation because earlier here in the other steps they added one more station. There are possibilities that the 4 workstations are not enough for all the tasks, so it added one more station. So our station now is 5. That's why what we add here is 5. Then the workstation cycle time, which is 50.4, we're going to multiply it both, and we will get the answer. And the answer of that multiplication, we are going to divide it into 195. So the answer will be 0.77, and because it is efficiency, or what we're going to get here is the percentage, we will going to turn it into percentage. We're going to move the dot into the right side for 2 times. So the answer will be 77%. And by this result, it is imbalance because there is still a 33% idle time. We have multiple possibilities for us to limit a time of a task. For example, we have here an example of a task that will take 40 seconds to make. So in order for us to limit that, we have 6 possibilities in order to limit or to minimize the time that will make the task. The first one is split the task. Next is share the task. Third is use parallel workstation. Next is use a more skilled worker. Next is work overtime. And lastly is redesign. We also have here a flexible and U-shaped line layout. This is what they use, an example for a toy company, for them to minimize the time of their task. Then they also have mixed model line balancing. This mixed model balancing, this was used by a Toyota company because they are launching many models or mixed models because of their demand.